This session is going to be leveraging ASVS into your secure SDLC. Our speaker has quite an extensive background in a number of different facets of security. He's been a practitioner. He's currently in a management position with Cerner, where his team has looked at more of the operational sides. He's worked on a lot of interesting projects that I'll let him speak to as time warrants. But I'd like everybody to give a warm welcome to Derek Fisher.
All right, thank you everybody for, can everybody hear me? Okay. All right, so thank you everybody for coming. I know it's after lunch, so I'll try to keep this, engaging. Hopefully nobody falls asleep. So just to get into it, I'm not the famous basketball player Derek Fisher. I actually got that today in the hallway or at one of the vendors' tables earlier. But I am not him. I will sign autographs though if you want to. I have been in engineering. I actually used to play basketball. I was pretty good, but I was not that good. I've been in engineering for about 20 years now. I started out in hardware engineering. I did a lot of mechanical and electrical design work, drafting. After about 10 years or so of that, I switched over, went to school for software engineering. Got into software engineering quite a while ago, and then took my graduate degree in computer security about 5-6 years ago, and have been in security for about 6-7 years. Primarily focused in application security, but a lot of the stuff that I've done has spanned a lot of different aspects of security, not just with application security, but also in the operational side, scanning, threat modeling, things like that. So I am from Cerner Corporation. Does anybody here know who Cerner is? Okay, so we're a healthcare company. We're the largest one in America today. My team's primary focus, and one of my team members is sitting up front, our team has been primarily focused in driving requirements into security. As I mentioned, we do a lot of threat modeling and other things as well. But our primary focus recently has been with security requirements. So out of that project that we've been working on, I just wanted to share with everybody here what we've kind of learned by leveraging the ASVS in our software development lifecycle. I don't need to go into depth here. That's the reason why we're all here, right? Security is important. That's why we all have jobs in this field. That's why we're all here to learn something new about security, or see things that we know that we already know some stuff about, but we want to learn more about. It needs to be a big part of what we do daily. Part of why we wanted to look into doing the security requirements in Cerner is that it kind of takes security out of the realm of specialists, the people that go and get their security degrees or go and spend a lot of time in security. Putting security requirements in the development lifecycle really kind of makes security more part of everybody, all the developers' life. It's no longer black magic to everybody. So one of for us, particularly with Cerner, is that health records are right now they're very lucrative on the black market, more lucrative than a credit card number. Primary reason is that when Target breach happened, my credit card, my wife's credit card, all our credit cards were compromised. We just called the bank and said we need a new credit card. That's not a problem, right? They just issue a new one, cancel the old one. If you get a HIV positive result, you get a cancer diagnosis, you can't call a doctor and get that changed, right? So these are valuable records and information, and not just with the health information, but also with some financial data that's associated with your health record, or even just personal information, your street address, your phone number, things like this are all part of, from our perspective in Cerner, that's all part of what we're trying to defend. Again, I think we've all seen similar concepts here. Solving defects early in the life cycle is far cheaper than solving them later on down the road. This one, again, we've all seen variations of this. This one came from 2015, showing that a bug or vulnerability found early on, it's $10 to fix it, or I'm sorry, $100 to fix it, as opposed to finding it in production when it's $10,000. So I took a quick Google search to find, to get the named vulnerabilities that were found in 2016. There's kind of like a running joke in security. I'm sure some of you have heard that, is that it's not really truly a vulnerability unless it gets a, an icon, a name, possibly theme music, maybe T-shirts. Obviously, the big one is WannaCry. Everybody's heard of that. Some of these other ones, top left is Drown, Dirty Cow, which is always funny to say. But there's obviously been a lot of vulnerabilities, and this is just from 2016. This doesn't even include like the ones that we've had recently with Experian and other types of vulnerabilities. But again, we all kind of, these are obligatory slides here about why we're doing the things we do. So we'll move on to security SDLC. Common software development lifecycle, and that's kind of an important point too. When I say SDLC, I'm meaning software, not necessarily system. So software development lifecycle. We have requirements, design, development, test, and deployment. Where we've been kind of focused from a security perspective, and not just with the ASVS, but from security in general, during the requirements phases, we attempt to try to map security controls to our requirement, or create requirements out of security controls. During the design phase, you can inject some threat modeling, some secure design reviews. Again, our team kind of has been involved in these types of meetings. During the development stage, static analysis and code reviews. There's a lot of people here talking about static analysis. It comes up frequently in a lot of the talks. During the testing phase, you have security test cases. Maybe you have abuse case type of test, and then dynamic analysis as well. And then during the deployment stage, you have a final security review. You do some application security monitoring. Maybe that also includes vulnerability monitoring on some of the technology stack that you have. You want to make sure that you're getting information on the vulnerabilities that are coming out. You can deploy patches, things like that. Where we've been focused with the ASVS has really been in the mapping of security controls and the security test cases, and that's where the focus the rest of this presentation. So you'll hear me say the word requirement. You may also hear me say the word control. So what we've done internally at Cerner is that we've started using the word control. Requirement means something, and some of the verification statements from the ASVS really aren't just functional requirements. When you think of functional requirements, you think of something that you can test. You can write a test plan for. Not everything in the ASVS is something that you could write a test plan for. So we started using the word control, and some of this will become a little bit clearer here in a minute. But if you haven't seen this slide, or if you haven't seen this graphic before, it's all over Google in different states. But it's basically one of the challenges that we have with writing requirements or controls is really trying to convey what it is that the requirement or control is trying to do. And everybody has a different interpretation of what that requirement is or what it should do. And not just from a development perspective, but all the people that are involved with writing or viewing or testing a control or requirement. Everybody has a different perspective on it. And we run into a lot of challenges with that. When we look at the ASVS verification statements, and we get in a room of people, some are developers, some are from just developers, some are security architects, some of them are solution designers or solution owners, or it kind of runs the gamut of the people that are involved with these. Everybody has a different take on what that statement means to them, which is a good thing because it allows us to kind of bring together people from different areas to really get their opinion on what they feel the control means. Testing. So obviously, one of the key challenges with security testing is that we can't always expect a test analyst to know how to properly test a control. So what I mean by that is we can say, from a security perspective, we can say something like make sure that your cookies are set for HTTP only. Test analysts are not, they're not security people. They're not always technical enough to know how to check whether a cookie is HTTP only enabled. So one of our other challenges with this project has been that we want to be able to write guidance. We started to talk about writing test plans originally, but we want to provide guidance to our test analysts to say, here's some common security, some common security things that you can look for. Here's what you should be looking for, or how you can do it, as opposed to being prescriptive about, like, here's how the test plan is written. So how many here know what the ASVS is? I apologize. Okay. So I apologize. I should have stated that ahead of time. So I'm just going to read directly from OWASP. The ASVS is a community effort to establish a framework of security requirements and controls that focus on normalizing the functional and non-functional security controls required when designing, developing, and testing modern web applications. It's kind of a mouthful there, but what we have found with the ASVS is that it's, the simplistic view of it is that it's a set of verification statements, right? It's a way to verify that a system is behaving the way from a security perspective, that you intend it to be behaving. So it's a good way of testing security from the end. Once the software is developed and deployed, it's a good way of testing to make sure that it's doing it in a secure fashion. One of the key points of the ASVS is that it's a common framework. It's something that, from a Cerner perspective, we've been doing security for a very long time. A lot of us have been doing security for a long time. One of the things is that we have a lot of different applications. Some of those applications may be doing the same thing as security, just not defined the same way. And I think that's what we were looking for with the ASVS, is that we wanted to have a common requirement across all of our applications to ensure everybody's doing it the right way. So for those that are familiar with the ASVS, you know the concept of levels. Within the ASVS, there's three. It actually starts at 0, but the 3 levels are actually 1, 2, and 3. For one, we think of this as for any application. So any application, period, would try to attain level 1. For any application that has some level of sensitive data, then we would say that they need to achieve a level 2. For those that are mission critical and have a high concentration of things like PHI, PII, PCI, if they're a medical device, things like that would be an application that would try to attain level 3. So you can think of level 3 as, obviously, that's the most, it needs to be the most secure application. So again, the ASVS is broken up into 16 domains. We are using version 3. So in version 3, you'll see there are actually a couple domains that were taken out. So there's a total of 16 domains. And you can see, for those that aren't familiar, that where the different domains fall in. So they, anything from architecture, authentication, session management, configuration. There's also a mobile section, just to kind of give you a sense of what's covered in the ASVS. Sorry, I was losing my notes there. So here's just kind of an example of some of the verification statements directly from the ASVS. You'll see a couple here from domain 1, 2, 3, 5, and 7. All I wanted to do with this slide is just kind of give everybody a sense, for those that aren't familiar, of what the verification statements look like, and the levels to the right are how they're applied, which level that those verification statements apply. So in other words, you'll see 7.8 at the bottom. That only applies for the most secure, for applications that want to be the most secure. For 5.5 and 3.7 and 2.18, they all apply to all levels. So just to kind of give you a sense for how the statements are what they look like and how they apply to the different levels. All right, so now on to the fun stuff. Take a sip of water here. So as I mentioned, we use the term control as opposed to requirement. Just wanted to, because from here on out, I'm going to attempt to use the word control. I joked before that we were going to have a little bucket where you drop a quarter in every time you say the word that you're not supposed to say. We never did that. But so what we actually did was my team, some members from the testing community, some members from our solution design, which is kind of like that's our application design level groups, and some people from our process groups. We all got together, and what we've been doing is what we did was we took the ASVS statement and we turned that into an actual control. So how we interpreted it was that the statement was, again, something that you would use to test whether the application was doing that. That's not actually a requirement. So what we did was go through here and start taking a look at each one and actually writing a requirement that we can give to development. So for the first one, verify that the application components are identified and known to be needed. What we actually wrote out as something that we would then push out to our development community is that a list of internally developed components such as libraries and modules shall be created. So really, the joke for those that may have written requirements has always been, it's just a sentence with the word shall in it, which, is kind of a shorthand way of writing requirement. Not always true in every case, but that's kind of the way we've been looking at these verification statements. See, like with 316, what we actually did was take that and break it into two, because we felt that there was enough content in the verification statement that it would be two different types of controls. Another thing that we did was create what we call security control types. The easy one is functional, and I apologize for the small font there. The easy one was functional, which is it's something that I can write a test plan for. A example of a functional security control is that a logout link shall be accessible on the main page of a domain when a user is logged in. You can write a test plan for that. You can tell the tester, go to the main page, make sure that you see a logout button in the top right corner. So that's something simple as far as a control that can be tested. The other type that we had was process. It's a list of internal, so process one is something that requires some kind of an input and an output artifact. So for process, one of the examples would be a list of internally developed components such as libraries and modules shall be created. What you would have as the output artifact for that is the list of components. So for those, again, you can't really write a functional test for that, so we determined that fit more into a process type of control. The third type was DevOps. So these types of controls were ones where it would require some kind of operational support. The easy one is HTTPS. An application needs to be able to support HTTPS, but at the same time, your operational team needs to be able to turn on HTTPS on the host that application is running on. Or the network team needs to make sure that they're capable of handling HTTPS. So for these types of controls, one of the examples is time sources on a server shall be synchronized with the current local time correctly. That's a DevOps type of control. The last one is kind of, I hate to say it, but it has been kind of a catch-all. So for these are what we call tech design controls. So tech design controls are ones that we could write a test plan for, or we may have the ability to write a test plan for. But at the same time, like something like an injection, you're trying to protect against injection. If you have an application with 100 text boxes on its main page, it's going to be difficult to write a test plan and tell the tester to go through and test each one of those to make sure that it's not susceptible to SQL injection. So what we decided was that for tech design, as a separate control, they're more related to the architecture ones, and what we're going to ask for is documentation saying, all right, how is this control being implemented? Can you point to some code review? or even your code repository to show where it's being implemented. So an example would be the component shall implement a tiered architecture model which separates data, controller, and display. There's no way that you can write a test plan for that. A tester's not going to be able to test that. So again, that would fall into a category of tech design, where we would ask the architect to, describe how their application fits into this, and then link out to some code review or some kind of code repository that shows how it's being implemented. So one of the things that we did as far as rolling this out to our development community, we actually leveraged Google's VSAC. So for anybody that's not familiar with that, it's a vendor security assessment questionnaire. It's a dynamic, interactive questionnaire that they actually give to their vendors that are trying to, be partner with Google. It's open source. It's freely available. What we actually did was we took it, we repurposed it for the purpose of the ASVS, and what we've done, and actually I'll get into this here in a second. What we've done is we've used the questionnaire to determine what ASVS level that application needs to be. So we ask a couple questions like, do you contain PHI? Are you mission critical? If the system goes down, is somebody going to die? Do you host things like cat videos? Because if that's the case, then you're level 1. But we ask some upfront questions to figure out what level of the ASVS that application should be. From there, behind the scenes, once you're at level 1 or 2 or 3, or once we've made that determination, that's my boss, by the way. So it must be important. Apologies. What do they say about demos? Nothing ever... Sorry about that. Can you ping him and tell him this? Okay, so what we've done with the questionnaire is, we've asked a lot of questions up front to say, hey, what level are you? And then behind the scenes, what we're actually doing is taking the list of controls that are applied to that level. So if you're a level 2, we've taken that subset of controls from the ASVS for level 2, and we've taken, those are the controls that that application would get. What we further did was, going through the list of verification statements, we understand that not every control in the verification statement would apply to an application. For instance, if I don't run my own authentication, if that's being offloaded to somebody else, I don't need to respond. I don't need to take on the controls that apply to authentication. Or perhaps I don't have a native mobile app, so I don't need to take on the domain that's related to mobile applications. So we've asked a further subset of questions to filter out some of the controls that don't apply to that application's architecture. So just a pictorial representation here of what I just mentioned is that we would ask a question, we would ask some questions that would filter out, like, what security level are you? Okay, the way they responded, they're level 2, they get 130 of the controls. From there, we'll ask questions about, which of the level 2 requirements apply. So again, do you have a native mobile application? Do you do your own authentication? Do you store passwords? Things like that. Once they answer those questions, they'll come out with a final list, and perhaps that's only like 80 of the controls that they need to take. All right, so what we've done is once they've answered those questions, and once we've made the determination of which of the controls that they need to take on, what we'll do is we will open up tasks on their defect tracking tool. In our case, we use Jira. So the kind of the drawing there that you see at the bottom there is that we take the requirements. We've actually named the dynamic questionnaire the SAVE. I can't tell you what it stands for anymore. But once the requirements are, the SAVE is where the requirements are generated. Once the team goes through the SAVE questionnaire and hits submit, JIRAs are opened up on their project queue. And from there, we're able to generate reports on what's been completed, what's being NA'd, not applicable, what's dragging on for too long, is there a lot of questions about stuff. We're able to generate those reports and supply them up the executive chain. And then more importantly, we can verify that the controls are actually being completed. So it depends. So the save, the question, the interactive questionnaire, that's what they would go through to ask them questions like, and I probably should have thrown this in here to show an example of what's actually listed on there. But the questionnaire will ask things like, like I said, do you have PHI, are you mission critical, things like that, and then it determines your level, and then from there it's going to say, do you have native mobile application, do you do your own authentication, how do you get your HTTPS certificates, and then out of that, the user will actually see the list of controls that would be opened on their JIRA queue before they hit submit. Once they hit submit, they all get opened up, as individual tasks on their JIRA queue, and from there, they would have to do the analysis to say, this one doesn't apply, this one does, this one's already completed. And actually, that's actually a good point. It sounds like a lot, if you're opening up 100 JIRAs on somebody's development queue, their head's going to explode, right? The expectation is not that all of these are net new things, right? So specifically like the logout button. Most applications are already going to have that. So and for them, it's just a check in the box. Are they using the HTTPS? Yes, they're checking the box. So there is some upfront analysis once those JIRAs are open that somebody has to go through and confirm that they're either doing it or they're not doing it, or that they need to dig up the information and supply that and all that stuff. But did that answer your question? I apologize. Yeah. So, but that would, once they respond to those, that'll make the determination of which controls they would get. So once they've responded to the questions, that'll filter out the list of actual controls that they would get, and those would get opened up as tasks on their defect tracking. It doesn't have to be JIRA, it could be anything, but it would be opened up on their defect tracking, and from there they have to manage the controls. That's just what we use internally. So I'm glad you brought that up too, because one of the things that I'm kind of a big proponent of is that I don't like to separate the difference between a defect and a security vulnerability. Right? I mean, you can make the argument that a defect is a security vulnerability, right? Because if it's properly exploited, you're making the system misbehave. So to us, one of the things was that we wanted to make sure that we're using the same tracking system, that it's something that we're not creating something new. A lot of what we're doing here follows, pretty standard process, and that's what we wanted to do, is to kind of make sure that we're not, the last thing development teams want is more work, or more tools to try to manage and go through. So we wanted to make sure that we kind of stayed within the process that we already have. So does that help? Okay. All right, so some of the benefits. Vulnerabilities suck. As I mentioned, it's not only just all the things that we've seen in the news and all the different, problems that we see within our companies, within other companies, again, just not separating the difference between vulnerabilities and defects. These things are, nobody's going to, these things are difficult for us to deal with in our industry. But one of the benefits with doing the ASVS is that we have this adoption, or we have this consistent set of security controls. It's something that we know that Solution A is doing this because they're going through this process. Solution B is they're going through the process. They've got the same requirement, the same security requirement. And that makes it a lot easier for us to do tracking and making sure that, you know, our solutions are meeting a security standard. Being able to provide reporting at the same, you know, kind of the same concept here. I mean, being able to provide reporting about where our solutions are from a security standpoint. You know, if we know that solution A is struggling compared to solution B, maybe the executives need to make a change, you know, or provide more resources, maybe apply some pressure on that team to make sure that they're, you know, catching up to the other teams. So it's a good way for us to kind of get a visual, at least at our company, across the board to match everybody against, you know, a common framework. I think one of the other things too is being able to, something I didn't really touch on here, but one of the things too is being able to provide some guidance from, you know, to our development teams on how to prioritize, you know, some of the issues. So maybe adding, you know, perhaps doing something like, I'm trying to think of, you know, not a non-essential, I don't want to say non-essential, but something like, you know, enabling HTTPS should take priority over something that's not, you know, is a little less critical. You know, I think it's a good way for us to, once you have that common framework, it's a good way for us to say, hey, these are the 15 that we need to focus on this year and make sure everybody's doing it. It's easier for us to do that if everybody's kind of reading from the same book. And the last thing, of course, is raising security awareness. You know, again, I think we all know this in the security industry. You know, we've, you know, done our training, we've been involved, we've come to these conferences. But if you're in a company of thousands or tens of thousands of developers, they're not all coming to these conferences. They're not all getting that training. So I think, you know, we obviously can't be the ones saving the world from a security perspective. Doing something like this puts security in front of the developers, makes it more prominent, helps them kind of make it more tangible to them, you know, in the form of a written control or requirement to say, oh, so this is how, you know, this is how security is supposed to look. It puts it more in terms that developers are, you know, accustomed to seeing as a requirement. So with that, I don't have anything else. If anybody wants to ask any questions, I'm available. If not, you can always catch up with me afterwards. So.
Yeah, we can line up at the microphone right here, or just put your hand up when you come around and bring a mic to you.
Hi. So on the slide where you talked about the Google questionnaire for the vendors, and then you talked about putting things in Jira. So are you saying that like there are some action items given via Jira to your developers for an issue that is found with a vendor? What?
Our questionnaire is internally developed. It's internally hosted, so we direct our development teams to that questionnaire. When they fill it out, we call Jira APIs to open up those, you know, those controls on their on their Jira project. But all that is internal. You know, it's all internally developed and designed. Does that help?
Thanks for that. I just had a question around at what point in the process do the developers go through the questionnaire? So is it during feature planning or sprint planning? I'm just wondering if you can elaborate.
I know I'm probably going to trample on what I said earlier, but I mean, this is kind of a new thing for our solutions, for our applications. So, we're actually rolling this out to the development organization, saying, "Hey, the responsible parties for this application need to go fill this out." So we're not doing this at any particular stage. It's more of a project that we're rolling out. You know, we're taking that kind of a view. So when when a application owner comes and does the questionnaire and they get their, they get their JIRAs opened up, it's then up to them to first knock out all the ones that they know they're already doing and then start slotting the ones that they're not. So it's more of a put these on the backlog, take the critical ones, get them slotted first, and then the other ones, they're lower priority, they can slot, further on down in their process. But again, it's not it's not something that we're doing in any particular phase because of the size, of these security requirements. That again, if you're a level 3 application, you're going to get a lot of security controls. You're probably, I think our final number was 214, 240. So by the time we took the ASVS verification statements and rewrote those as security controls, we had a total of 240. So if you're a level 3 application, you're going to get 240 JIRAs opened up on your queue potentially. That's a lot of work, right? So, so we're looking more of this as a rollout project as opposed to some particular stage in their SDLC. Does that help?
Yeah, thank you.
And as you work to define the controls, how typically short do you like to keep them, I guess, so that it's understandable for everyone that may have to, try to read them and digest them and understand what's involved?
Yeah, that's been a pretty good struggle too for us. And I think part of what has helped us is that we've had a broad range of people that have been involved with it. So it's not just the development people, it's not just the security people, but we've also included testers and designers and things like that because we want to make sure that the security people can read some of these controls and say, yeah, I got it, I understand what that means. But a test analyst or a solution designer is going to look at it and say, I have no clue what that is. So we've been wanting to kind of get that input so that we can write the control in such a way that it can be interpreted by different parts of the organization. One of the other things that we're including is a lot of documentation, a lot of guidance. This is what this means. This is what our glossary, the ways that we're trying to provide testing guidance as well, for our testers. So there's a lot of accompanying documentation that I think we're going to be relying on heavily. But we're kind of viewing this as it's going to be an ongoing process. Satish and I were talking last night. I mean, it's going to take us, we're going to be involved with this for years as we kind of build out all the information and provide guidance for everybody. So I hope that helps.